Okay, so now the topic is about the probability distribution. Now, this word probability, we have been studying about this since our 11th, 12th standard. Even in 10th standard, we had a basic of this. Okay, now in this part for you all, a direct question that find a probability of this event, such a question won't appear, but its use in some other kind of distribution will be asked. Okay, so now for knowing this or for solving this kind of problems which involves this probability distribution, and to understand its types, the three types of probability distributions, we will give a brief touch to this, the concept of probability. Okay, now a most common example of this probability part is of throwing a die or throwing a coin, suppose. Okay, now throwing a coin, you don't know what can be its outcome. You only can predict the outcomes. That is what, either you have two options, that is either you will get a head or a tail, but you can't tell sure shot. Okay, now such kind of experiment, now throwing a coin is an experiment in itself. Okay, now such kind of experiment in which you can only predict about the outcomes, that is you can just give a hint or you can just list the possible outcomes or the possible results which will appear. Okay, they are called as random experiments. Okay, these are some technical terms, let me be very clear with that. Now random, now suppose you are heating any solution, okay, or heating a water. Okay, you are providing a temperature to it. Now you know its outcome. Outcome is what? Outcome is a result. Okay, now you know its outcome, that the temperature of the water is going to rise. Okay, so if your experiment is boiling water, or okay, its outcome is a sure shot outcome that its temperature is going to rise. Okay, now this is not a random experiment. Okay, but if you compare the same with this throwing of a coin experiment, then there are two chances, that is getting a head or a tail. You cannot tell anything about that. Okay, and both have 50-50% chance. Okay, or even about throwing a die, what are the possible outcomes which can come? That is, you can get a 1, you can get a 2, you can get a 3 or a 4 or a 5 or a 6, right? So such kind of experiments are called as random experiments, and this getting a head or getting a tail or getting a 3 on a die, they are the events. Okay, and this listing out of all these possibilities or possible outcomes, they are called as sample space. This set, okay, this set are called as sample space. Okay, now coming back to this probability. Now if I want to calculate the probability of getting a head when one coin is tossed, now so probability of getting a head, that is what. Now, see the formula for probability of any event is given by number of favorable outcomes upon the total number of outcomes. That now the total number of outcomes means what? All those elements, the number of elements which are listed in the sample space. Now, what can be the total number of outcomes of this? Now, throwing a coin means what? Only two outcomes are possible. That is either getting a head or getting a tail. That is what, two outcomes are possible. Therefore, total number of outcomes are two. Okay, and number of favorable outcomes. Now, favorable to what? Favorable to the given event. Now, event is what? Getting a head. Now, what is favorable to it? That this edge, that getting a head is favorable to this, and it can occur how many times? It can occur only once. Therefore, it is one. That is the probability of getting a head is 1 by 2. That is half. Okay. Now, similarly, probability of getting a tail. Okay, if I want to find a probability of getting a tail, it will be Again, total number of outcomes will not change, it will remain as it is, that is 2. Okay, and but now the favorable outcome is what? Getting a tail, that is only one number favorable outcome, that will, again, the probability of getting a tail is half. Okay, now if I consider the example of throwing a die, and now in this, if I want to calculate the probability of getting a number 3. Now you know this very well. How many total outcomes are there? We had counted. How many numbers are there in the sample space? One, 2, 3, 4, 5, 6. Okay. So total number of outcomes are 6. Now probability of getting a number 3 is what? How many times a 3 can appear in the sample space? That is what? One, only once. 3 is appearing only once. That is the number of favorable outcomes is only 1. Therefore, it is what? 1 by 6. So, probability of getting a number 3 is 1 by 6. Or the probability of getting a number 4 is 1 by 6. Probability of getting a number 5 is 1 by 6. Okay. Now, if you see, if I want to calculate the probability of getting an, an odd number. Okay. Now, again, the total number of outcomes will not change. Total number of outcomes are 6 in this. In throwing a die experiment, only 6 outcomes are there. One, 2, 3, 4, 5, 6. Okay, so this will not change. It is 6 as it is. Now, what will change is total number of favorable outcomes. Now, favorable outcomes to this, getting an odd number. How many favorable outcomes are there? How many, that is how many odd numbers are there? 1, then this 3, and this 5. That is how many total favorable outcomes are there? This 1, 2, and 3, that is 3 outcomes. Okay, so 3 are the favorable outcomes, therefore it will be 3 by 6, that is 1 by 2. This is the probability of getting an odd number. Or probability of getting an even number. It will be again same. The total number of outcomes will not change. It will be 6 as it is. And now in this case, what will be the even numbers? 2, 4, and 6 are the even numbers. That is again 3 even numbers we have. So what is that? The probability of getting an even number will be 3 by 6, since my favorable outcomes are 3 in number, so it is again 3 by 6, that is half. Okay, now next is about probability of getting a number greater than 4, strictly greater than 4. Okay, now greater than 4, how many numbers are there greater than 4? Greater than 4 are 5 and 6. Okay. Now greater than 4 are 5 and 6. That is, again, total number of outcomes will be 6 as it is. Now only the favorable outcomes are this 5 and 6. That is what? How many are they? 2. So that is 2 upon 6. That is 1 by 3. Okay. Now similarly, probability of getting a number greater than or equal to 4. This example I gave purposely. Why? Because just to just to notice the difference between this strictly greater than 4 and greater than or equal to 4. Okay, now I want to calculate the probability of getting a number greater than or equal to 4. Again, the total number of outcomes will not change. Okay, so that will be my 6 as it is. And now, how many favorable outcomes will be there? What is the number greater than or equal to 4? Yes, 4 is a number which is greater than or equal to 4. Okay, it is equal to 4. Now 5 is a number which is greater than 4, and 6 is a number which is greater than 4. So basically in this case there are 3 favorable outcomes, so this comes to 3 by 6, that is half. Okay, so we need to strictly understand this difference. Okay, now again, if I want to calculate the probability of getting a number which is prime. Now again the total number of outcomes will not change, that is 6. Now which are the numbers which are prime? Prime numbers in 1, 2, 3, 4, 5, 6 are 2 is a prime, 1 is not a prime, okay? 5 and 3, these three numbers are prime, okay? So 2, 3 and 5, that is 3 by 6, that is half, okay? So this is the basic problems, or the most common problems which we appear. Okay, now if I want to calculate a probability such that if two coins are tossed, two coins are tossed simultaneously, that is what? Together these two coins are tossed. Now this is coin 1, coin 2. How will be the things? I can get a head here and a head here. Yes, okay. Or on coin 1 I can get a head, and on coin 2 I can get a tail. This is fine. Now on coin 1 I can get a tail, on coin 2 I can get a head, on both the coins I can get a tail. Okay, so that is total 4 possible outcomes are there. That is what? Head head, head tail, tail head, and tail tail. Yes. So now in this case, the sample space of tossing two coins simultaneously has total 4 outcomes. That is 4 elements are there in this sample space. Okay. So now if I want to calculate the probability of getting two heads, okay, now getting two heads in this experiment. Now how many total number of outcomes are there? One, two, three, four. That is 4 outcomes total. This is one outcome, this is second outcome, this is third outcome, this is fourth outcome. Okay, so total fourth outcome. Now out of this, in how many uh, outcomes there are two heads? Only in this outcome. Yes, that is how many favorable outcomes? One. That is 1 by 4 is the probability of getting two hits. Similarly, probability of getting two tails is what? Will be again 1 by 4. Now if I want to see probability of getting one head, will be what? Now how many, at how many places there are one head? This has two heads there, so this is a different case. Now strictly one head I want, so this is the one, this is another one. Okay, so only at two places. That is what? How many are favorable outcomes? 2 divided by the total number of outcomes, that is 4, that is 1 by 2. Okay, now